And up back, polyatomic ions. Here we go. Polyatomic ions are groups. Remember at the beginning of the last video we talked about groups or individual atoms that have a charge. Polyatomic ions are polyatomic ions. So this is a group of atoms that has an overall charge. So are groups of two or more bonded atoms that have lost or gained electrons and thus have an overall net charge. So an example would be a carbonate ion. That's CO3 2-. That's one carbon atom bonded to 3 oxygens and it has gained 2 electrons for a -2 charge. The ammonium ion, NH4, one nitrogen atom, 4 hydrogen atoms, and it's lost an electron for a +1 charge. Okay, most of your polyatomic ions are going to be anions. So here's the common polyatomic ions. Ammonium, acetate, bromate, carbonate, chlorate, cyanide, hydroxide, nitrate, phosphate, sulfate. Okay, now I'm always at a little bit of a crossroads. I don't think that memorization of these is really worth your while, and I don't think that it really, I just have trouble believing that it tests anything other than your ability to, memorize, and that's not the point of a chemistry class. I will say that knowing these and being able to recall these very quickly is helpful on homework, and it's going to be helpful and it's going to save you time so that you don't have to look back at what these different formulas are. If there are some that I would recommend you focus on, I would recommend that you commit the ammonium ion to memory. I would recommend that you that you're kind of familiar with the acetate, carbonate, cyanide, and hydroxide ion. The rest of them, you'll see them surface from time to time, and they'll be in practice problems, but I don't think that I do not believe that if you do not have these committed to memory, you're at a total loss or anything. These are going to resurface later on in this semester when we talk about solubility of different compounds. So I think that it's helpful, but I don't think it's worth your time to do flashcards on any of these. If you want to, go for it, but it's just not going to, there's not going to be 10 questions that are like, what's the sulfate ion? Okay. Now, with that said, these 5 that I highlighted, those are kind of a little bit more fair game. Okay, but I would say, yeah, ammonium, definitely, because that's the only cation. Hydroxide, feel pretty good about that one. And anyway, these are your polyatomic ions. Notice the charges. Most of them are negatively charged. There's -1 charges, -2, -3 charges. Phosphate ion is -3, sulfate is -2. Most of the rest of them are -1s though. Writing formulas of ionic compounds with polyatomic ions. What you want to do is you want to use the least common multiple to determine the subscripts needed to balance those positive and negative charges. Enclose the polyatomic ion in parentheses. This is a very important thing because it's important to remember that that polyatomic ion, that is a group, that is a grouping, that is a molecule that has come together that has a designated charge. And that will also help you when you're balancing chemical reactions and precipitation reactions. Okay, so how would you write the formula for CaNO3? Well, what you're going to want to do is you're going to want to say, well, this has a +2 charge, this has a -1 charge. You have 2 NO3 ions that are needed to basically negate the charge of that calcium. So you'd write it as CaNO3 and then put that 2 outside the parentheses. That indicates that that NO3 is, well, kept intact and that there are 2 of them. Now, determine the formula of the compounds from these, compounds formed from these ions. So Cr is 2+, SO4 is 2-. CrSO4. There's not a need to put that SO4 in parentheses because you don't have to use a subscript there. Now, Cr3+ and CO3 2-. This, you know that you're going to have to use the subscript for the CO3 or the CR because of the fact that these two charges, +3 and -2, they don't cancel one another out. Now, if you write CR, you need 2 of them, so 2 of these and 3 of these to get to a -6 and a +6 respectively. So if we're at CR2, parentheses CO3, and close parentheses, then put a subscript 3 down there, you're good to go. Now with that said, one of the things that people always struggle with is doing this little math here where they say, okay, I got to multiply this by 2, multiply that by 3. Here's a little trick. CR3, CO3, 2 minus. Now, the way that you can kind of save yourself some stress is by, and this is to write out the formula of this. Circle that number. That's going to be the subscript for this. Just the number is going to be the subscript for this. So CR2, parentheses, CO3, 3. Okay. I hope this is helpful. We'll continue forging ahead.